Okay, in the last of our short videos, we introduced something which we called algebra. And doing algebra, although it sounds really difficult, algebra is a sort of difficult word, isn't it? Although it sounds really difficult, it's really, in reality, it's really, really easy. It's kind of like being a number detective. We have to find what numbers fit in certain arithmetic expressions, certain strings of symbols of arithmetic, so certain strings of numbers and an equal sign and other strings of numbers and operating symbols and so on and so forth. Anyway, let's just try to cement this idea, to make this idea about algebra and show you how simple it is. Let's try to cement it by doing some problems. Now let's start off with this. I'm going to ignore those little dots that I wrote there and wrote on top of them. Let's suppose we have x. Somebody tells us that x plus 4 is equal to 6, and we have to find out what x is. How do we do it? Well, remember, the number on the left hand side of the equal sign, this is written out in long form here, it's a rather long way of writing a number, is the same number as 6. So x plus 4 is the same number as 6. So if we take 4 off of x plus 4, what do we have left? We have x, and so we have to do the same over here. Take 4 off. Whoops, I was going to do 4 there. 6 minus 4. And what's 6 take away 4? Well, it's simply 2. So if x plus 4 is equal to 6, then x must be 2. And let's put it back here. 2 plus 4 equals 6. Yes, indeed it does. So that's how we find what x is supposed to do. Now I'm just going to separate that, whoops, with a line. Gosh, my lines are really wonky. They're almost as bad as my handwriting. Now let's do another little problem. Let's suppose we're given something like this. Let's suppose we have one number which is x minus 2. We don't at the moment know what that number is, and because that's one number we put it in brackets here to signify that that's a number, and we have to multiply that, that's one number, by, and we'll put this in brackets too, x plus 1. And let's suppose that x minus 2 multiplied by x plus 1, that's supposed to be a multiplication sign, by the way. It's not supposed to be another x, and that's why we write x in these sort of squiggly way, what we call an italic face to them. We give them a bit of a squiggle so it doesn't confuse with a multiplication sign. And let's suppose that we know x minus 2 multiplied by x plus 1 is equal to 0. Now we've got to find what x is, or what x might be. How would we do that? Well, now here's a trick, something that you might know, but let me just tell you. If we have any two numbers which are greater than 0, 1, 2, 3, 4, whatever, and we multiply them together, any natural numbers other than 0, and we multiply them together, then we get another natural number greater than 0. So 1 times 1 is 1, which is more than 0. 1 times 2 is 2, which is more than 0. 100 times 11 is 1100, which is more than 0, and so on and so forth. Any numbers greater than 0, if two of them are multiplied together, they always give us a number which is greater than 0. But here we want to know what numbers multiplied together give 0. Well, only a number which is not 0 multiplied by 0 is equal to 0. Either two zeros multiplied together, nothing times nothing, no nothings are nothing, or no ones are nothing, no twos are nothing. Only something multiplied by 0 is equal to 0. So one of these numbers must be 0. Let's suppose, so either, what we know from that is either if those two numbers multiplied together are equal to 0, then one of them must be 0. So either x minus 2 is equal to 0, or x plus 1 is equal to 0. Now let's start over here. Let's write down, I'll do this in red actually just to make it a little bit easier hopefully. Whoops, that's not red at all. Okay, let's do case 1. Suppose my handwriting really is dreadful. Suppose x minus 2 is equal to 0. Then what's x? Well, we add 2 to both sides because they're both equal. X minus 2 plus 2 is just x, and 0 plus 2 is 2. So if x minus 2 is 0, then x is 2. And let's do the second part of this. Suppose x plus 1 is equal to 0. Then we subtract 1 from each side. We get x plus 1 minus 1 is just x. And 0 minus 1 is a negative number, minus 1. And that is supposed to be an e. So, either, just putting those two together, what's our answer? Either x is equal to 2, or x is equal to minus 1. It could be either of those things. Both of those, and only those, will make this true. So we put in 2 here. 2 minus 2 is 0, multiplied by anything is 0. That would work. X is minus 1. Well, minus 1 minus 2 is minus 3, multiplied by minus 1 plus 1, that's 0. 3 times 0 is indeed 0. So only if x is either 2 or minus 1 does this work out to be true. Any other values of x will make this false. Okay, now let's draw another of my squiggly lines here, and we'll do another one of these problems. Let's suppose we know that 3 times x, instead of writing 3 times x, let's just write 3x. 3x is equal to 12. Well, divide each side by 3. They're the same numbers, so we have to do the same to each of them. 3 lots of x divided by 3 gives us 1 lot of x is equal to 12 divided by 3. And 12 divided by 3, how many 3's go into 12? 4 lots of 3's make 12. So x is equal to 12 divided by 3, and that is equal to 4. So x is equal to 4. If 3x equals 12, then x is equal to 4. Well, that's a bit better line. Still not very good. And let's try another one just down here. Let's suppose 9 divided by x is equal to 3. Now, just to stray off the algebra for a moment, and to talk about a matter of notation, how we write things, let me just say that instead of writing 9 divided by x like this, that is a 9 and then this division sign of a line with a dot above it and a dot over it, sometimes we can write, in fact we generally do write 9 over, and we put a line underneath the 9, and then underneath that line we put x. And 9 over x is just another way of writing 9 divided by x using this sign. So instead of using this sign, we put the 9 over the line in place of the top dot and the x under the line, and it means the same thing. So here we have another way of writing this is 9 divided by x is equal to 3. Now if 9 divided by x is equal to 3, let's find x. Well, first of all, we multiply both sides by x. So 9 divided by x multiplied by x is just 9. And then 3 multiplied by x is 3x. Now let's divide each side by 3. By 3, 9 divided by 3, and that is equal to 3x divided by 3. 3 lots of x divided by 3. If they're split into 3, what do we get? Well, we just get x. So 9 divided by 3 is equal to x. What is 9 divided by 3? How many 3's go into 9? Well, 3. Lots of 3's make 9. So 3 equals x. And of course, if 3 equals x, then x is equal to 3. So we found out what x is. 9 divided by x equals 3. That means that 3 is what x happens to be in order for that to be true. Now let's just do one more, and I'll need a fresh piece of paper. Let's suppose we're told this x, and remember we can use other letters to stand for numbers that we don't know in algebra, and we use y and we use z and so on and so forth. Let's say this: x divided by 2y is equal to 4. Now we've got two unknowns here. One is the x and one is the y. Well, let's just move along here and multiply each side so we get rid of the division by 2y. Now x divided by 2y multiplied by 2y just gives us x, and then that must equal 4 multiplied by 2y. 4 lots of 2y's. Well, we have 8 y's. 4 times 2 times y, which is 8y, because 4 times 2 is 8. So x equals 8y. Now that's as far as we can go. We can't. X might be all sorts of things. If y is 1, then x would be 8. X is 8, y is 1. That would make that true. X might be 64 and y might be 8, because 8 times 8 are 64. So if x is 64 and y is 8, that would make that true. There are all sorts of pairs of numbers for x and y that would make that true, and we don't know which one is the one that we want. But now let's suppose that we're given some further information. Let's suppose that we know, in addition to this, we're also told that 2x is equal to 12. Well, now let's focus on this bit of algebra over here. If 2x is equal to 12, we can divide each side of the equal sign by 2, and that would give us x is equal to 12 divided by 2. 12 divided by 2 is 6. Now we can take that, let me just change color. Now we can take this, what we've just found out to be x, across to here. And remember, because there's an equal sign here, anywhere we find x written, we can now write 6, and anywhere we find 6 written, we can write x. So here, applying that in this part of the problem that we've got over here, we've got x equals 8y, but x is 6, so we can write 6 equals 8y. And if 6 equals 8y, well, let's divide each side by 8. 6 divided by 8 is equal to 8y divided by 8, which is just y. So y is 6 divided by 8. Now what is 6 divided by 8? Well, it's what we call a fraction, and we can make it a little more simple. We can divide 6 divided by 8, if we do top and bottom by 2, we can say that's 3/4. So y is 3/4. Let's just write that down. Y is 3/4. Now notice I've written 3 over 4. I've written it with a bit of a slanted line here as opposed to the flat line, which is the way we write fractions some of the time. So y is 3/4. If x is 6, then y is 3/4. And that is the last the last little problem I'm going to do in this introduction to very simple algebra. And algebra really is simple. Don't be intimidated by it.